Okay guys, so we didn't get to number 2 in the notes today, so I'm going to do that in this video. But first I want to notice a couple things about the parent function that we looked at today. I want you to notice that this function right here is the same thing as when I write it like this. Y equals 1 over x plus or minus 0 plus or minus 0. What does that mean? Well, that means that this function is the same thing as saying, hey, my vertical my left and right shift is 0. I'm not shifting anything left and right, and I'm not shifting anything vertically. Okay? So now that we know that, and now that we can see that that's the same thing, we'll be able to make some comparisons to number 2, which will help us out. But let's graph the parent function again, just because. So I know that I have no vertical or horizontal shifts, so my little center will be there, and I know that my asymptotes stay the axes. So my vertical asymptote stays the y-axis, and my horizontal asymptote stays the x-axis, okay? So what does that mean? Well, that means I'm going to just graph the function the way that we did in class. You move one unit out diagonally and mark that point, then you do the same thing the other way, and you make sure that your graph, you change colors, that your graph is approaching your asymptotes. So it should come like that and like that. And again, I'm just approaching but not touching my asymptotes, going right through that point. So that's how my graph is. And you will see the same graph if you decide to plot those points. Take any points and plot them. Any point besides 0 in the denominator. So take any x values and plot them, and it will come out as that graph. This is just a shortcut so that you can graph these easier. Okay, so let's keep this in mind about how we could write our parent function to look this way as well. And let's move on to number 2. Number 2 says, it's asking us to graph the function y equals 1 over x minus 1. Now, notice that is the same thing as y equals 1 over x plus or minus 0. It doesn't matter if it's plus or minus 1. Minus 1, okay? So, today we learned that this piece right here tells me what? It tells me about what my horizontal asymptote is. And the horizontal asymptote is going to go through the y-axis. So that makes sense why it might have something to do with our up and down movement. Okay, and this piece right here, this tells me about my vertical asymptote. And we know the vertical asymptote goes through the x-axis, so it makes sense that it might have something to do with our left and right movement. Okay, so let's graph those asymptotes. Well, I know my horizontal asymptote is at y equals -1, and my vertical asymptote would then be at x equals 0, because if I set this bottom part equal to 0, if x plus 0 equals 0, that means x equals 0, and if x minus 0 equals 0, that means x equals 0 in the same way. So let's graph those asymptotes. What is the line x equals 0? It's this line. Okay, it's just the axis, the y-axis. What is the line y equals -1? It's this line. It's the line that passes through y equals -1. So these are my horizontal asymptotes. And as you can see, that little center point has now shifted to be here, which is the intersection of my two asymptotes. So what I'm going to do, how am I going to graph it? Well, I'm just going to go ahead and graph the parent function again. So I know I move one unit out this way, right? So here's my new point. And I move one unit out this way. So here's my new point. It's right there. And now let me graph it using those asymptotes as my guidelines. Okay, so from this point, I know I'm approaching the asymptote, never touching it. And I'm approaching the asymptote, never touching it. And here, going up, approaching my asymptote, never touching it, and I'm moving to the right, approaching my asymptote and never touching it. Okay, so I finally graphed this function that's stated in number 2. I finally graphed this. Okay? The actual graph of the function is in green. The asymptotes are in pink. So let's analyze the graph. Okay? It first asks, what is our shift? Well, we know that we don't have a horizontal shift. We don't have a left and right movement because it's just plus or minus 0, and 0 is nothing. So you don't have a left and right shift, but you do have a vertical shift, and we can see that we have shifted down. Our center point used to be in the origin, and now we've shifted it down to -1. So your shift is down 1. Okay, let me write that. I'm going to start new over here. So down, so shift. What's my shift? And that is down 1. What's my horizontal asymptote? Let's look at this. We already figured that out. Which line is going, moving to the left and right? Which line is horizontal? And that's the line y equals 1, which we said right there. So my horizontal asymptote equals the line y equals -1. Okay, what's my vertical asymptote? It's that asymptote that is moving up and down. We're never touching the y-axis, so it is the y-axis, but we can also write that line as x equals 0. That's my vertical asymptote. At x equals 0. What's my y-intercept? Well, think about it. How do I find a y-intercept? Y-intercept. This is pretty bad. Hang on. Y-intercept. Y-intercept. How do I find it? Okay, so when is the graph going to intercept the y-axis? All right, look here. The graph won't intercept the y-axis unless it goes through the y-axis, right? Are we ever going through the y-axis on this graph? Our y-axis is actually an asymptote. Is it ever going to be the case that something like this blue line happens where we pass through it? No, because you can't touch an asymptote, right? So we have no y-intercept. I did this in class second period, so let's talk about it here. You can also find your y-intercept by doing what? By letting x equal 0, because we know that if we're passing through the y-axis, that corresponds to this x value down here when x equals 0, right? So we let x equal 0 to find our y-intercept. Okay, so what happens if in the function y equals 1 over x minus 1, what happens when we let x equal 0? We get y equals 1 over 0 minus 1. Can we ever have 1 over 0? The answer to that question is no, you can't ever have 1 over 0. So right away I know it never will intercept the y-axis. X-intercepts. Okay, what's happening there? That means that we're intercepting the x-axis. Okay, so right when I hit this point, what is my y value? That corresponds to some x value and some y value, and that y value is 0. So that means that we're trying to find, when we try to find the x-intercept, we're letting y equal 0. Okay, so let's do that. So x-intercept means that we let y equal 0. So we say 0 equals 1 over x minus 1. Now I want to solve for x. So I'm going to add 1 to both sides. So I'm going to have 1 equals 1 over x. Excuse me. I know 1 is the same thing as 1 over 1. Okay, so we can just cross multiply because we have a variable we're solving for. So we say x equals 1 times 1, which is just 1. So that's our x value of the x-intercept. But we know that the y value had better be 0. So our coordinates are 1, 0. for our x-intercept. Now, a lot of you guys said that you were having trouble with finding domain and range on the exit ticket today. So we're going to talk about domain and range real quick. Okay, what does domain mean? Think about what the word means before you draw a conclusion, okay? Domain means everywhere that x is being defined. So where is x being defined? When I say x being defined, maybe this is confusing people. I mean, where on the function, if I find any ordered pair, will I have an x value? Okay, where will I be given an x value on this function? So where does these green lines that create my function, where do they have an x value that corresponds to them? Well, everywhere that the green line is, there should be an x value. I mean, you can't have part of your function just have a y value and no x value, right? So that's why I say everywhere that the function is defined on x. So where on the x-axis is the function defined? Okay, so if I'm talking about an interval, so I'm talking about the x-axis. Where is it defined on x? I am moving to the left. I start from the left, move to the right. It's defined here, it's defined here, it's defined here, it's defined here. It's defined all the way up until I basically hit that asymptote, right? And that asymptote is at what? X equals 0. So it's defined all the way from the left, from negative infinity, all the way up to x equals 0. But we're not done, because we also have more of the function on the other side. Hang on, let me undo these red lines. Undo, 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 undo. Okay, so we agreed that it was defined from negative infinity all the way to 0. But we're not done, because I also see green on the other side of this asymptote. Okay, so it's not touching the asymptote, but it's in union with what? In union with 0 all the way off to infinity, because it's going to keep being defined. I'm always going to be able to find some x value for the function as long as I keep moving to the right. Okay, so that's my domain. What about my range? My range is, where am I going to find a y value? I guess we can also think about this is look at the y-axis and say, where on the y-axis corresponds to part of the function? Is there any part of the y-axis where my function is not existing there? And that should be pretty clear to you that it's not existing where my asymptote is. And we know that our asymptote is when y equals -1, right? That's where on the y-axis that the function is not defined. It's when y equals -1. So it's everything but y equals -1. That's also an appropriate answer. But how would we write that? Well, we know, I'm just moving down here. So the range, we know that everything, all numbers, right? All numbers can be written as negative infinity to infinity. I mean, can you find a number outside of this? Can you find a number outside of negative infinity to infinity that's real? You can't. So all numbers are defined in this interval, right? But we're saying it's all numbers besides when y equals -1. That's why I could write it saying, okay, negative infinity all the way up to when it reaches -1, but not including -1, in union with -1 all the way to infinity. And that would be your range. Okay, maybe we'll try to talk about range like that from now on, if it helps. Okay, so we got the domain and range. Let's talk about the intervals of increase. All right. What's happening here? Look at the green. If I stand on my function and keep walking, am I ever going to be increasing? Well, let's say we're standing right here, and we just keep walking. It looks like I'm going to start sliding down eventually. I'll eventually start sliding down, so I'm never going to be increasing. Actually, I'll always be sliding down, but you might not feel it as much here because it's less steep. But as you keep walking, it gets even more steep, and you just keep sliding down. Now, what if I start right here? Okay, I'm obviously going to be sliding down real fast. And as I keep going, the sliding is going to be moving slower and slower, but it's still always going to be decreasing. So I'm not going to have any intervals of increasing. Everywhere on that graph, it will be decreasing, okay? So your answer to that is no intervals of increase, but instead you have intervals of decrease. Now, when we talk about intervals of increasing and decreasing, we're talking about intervals in relation to the x-axis, okay? So where on the x-axis is it decreasing? Well, it's decreasing everywhere the function is defined. And we already found out where the function was defined on the x-axis, right? We called that the domain. Since the function is decreasing everywhere, that means it is decreasing on the domain. So the interval of decrease is the same thing as your domain in this case. End behavior. Okay. What is happening as x approaches negative infinity? Okay, look at these lime green lines again. This is our function, okay? We want to know what's happening to the y values of the function as the x values of the function approach negative infinity. Okay, so as I'm moving this way on my x-axis, as I'm moving that way, let me change the color. As I'm moving that way, which way or what is my y value approaching? On the graph, it's never going past this asymptote here, this dotted asymptote. It's never going past that. So you can't say it's approaching negative infinity. I'm asking if x is approaching negative infinity, meaning if I'm moving to the left on the graph, what is y approaching? So you look at the y, you look at the up and down part of the graph, the vertical stuff. And it's the ceiling. There's a ceiling on that function. And that ceiling is the line y equals negative 1. So the end behavior is as x approaches, okay, end behavior. As x approaches negative infinity, my y values approach negative 1. Okay, now let's see what happens as x approaches infinity. Okay, so look at the green over here. Now we're approaching infinity, so we're looking this way on the graph. Okay, what's happening to the green values? There's a floor there. They're decreasing. It's decreasing over there, right? I mean, if I keep walking to the right on my function, I'm getting lower and lower and lower, but I can't go to a certain low point, and I cannot hit when y equals negative 1. That's the floor of the function. So you can't touch it. So as x approaches positive infinity, y approaches 1. And in this case, y equals f of x. It's the same thing, okay? I meant to put negative 1 there. All right, so that's it for number 2.